All right. Thank you, Dave. So let me introduce myself a little bit for those of you that don't know me. My name is Daina Pettit. I know it looks like Diana, but it's pronounced Dana. And I work for Bluehost. I work for a lot of different companies. I have 2 different email addresses you can reach me at. One at my work, dpettit@bluehost.com, or my personal one, dana@xmission.com. So here we're going to get into some of the Perl stuff, ugly details that usually as a beginning programmer you don't get into. Map, grep, and sort are usually considered a little bit advanced. And because of that, there's a lot of people that don't get into them right away, and those that do see some great powerful things. Now, one thing a little bit behind Perl, those of you who have been in Perl for a while know who Larry Wall is, probably have seen this quote before. He actually gave this at a conference quite a while ago. But this is somewhat true, where you have people who are into Perl and they think it's the only thing. And so those of us that have been into it for a while really kind of believe that it's a great thing and love it. So we're going to get into some of the ugly details about this that make Perl so great. So first we're going to go over what is map, grep, and sort, and how we use them, why we should care about them. We're going to go into details on each one and show you some of the various things we can do with them, some of the efficiencies we can have doing one way or as opposed to another way. And then we're going to combine them. And this is where we get some real fun, powerful stuff that will really shorten your code and hopefully will make it more easily understood and maintained. And then we're going to talk about, in these combinations, we're going to talk about the Schwarzian transform, the Orcish maneuver, the Gutman Rossler transform, and some other alternatives. So basically, map, grep, and sort are pipeline type functions where they accept as an argument an array or a list of things, and they return you a list or an array of things. And the cool of that is they operate on them and do things with them. And so the kind of things that they do is map performs an action on each element. That action can be very long and complicated. It can be very simple, just a single item. Grep tests each element. And then sort will order them for us. The general form is very similar. So map, you give it an expression. It performs that expression on each item in the list and returns you a list. Grep, you give it an expression. It performs that test. And if that test, the value of this expression happens to be true, it returns that element in the list. So grep functions much like the command line sort in that you can return things, just the things that match. Sort has a similar form, but it's reordering the elements, so it's a little bit different process than map and grep. There's an alternate form without the code block, where you just give it an expression and you use a comma. Notice there's no comma when you're using the code block. Then sort, we have some other alternatives there, and we'll talk about those when we get to sort. Now, Perl's best practices, Damien Conway recommends to always use the block instead of the comma form. And the reason why is it's really a syntactic help so that we don't accidentally get the wrong thing happening, so that we have our thing that we're performing inside that code block. One of the problems with the block is it does give us a little bit more overhead. So if you're trying to squeeze every little bit of performance out of your code, drop your blocks. Map is essentially just a ForEach loop, or we could call it a for loop, either one, where we're giving it a list, we're going through an item at a time, performing some function on that. So it's kind of like this. So a somewhat equivalent map function would be like this, where we say map, and then we call the UC function, which does an uppercase. Now inside that expression that you're giving to map, it uses the current element as $_. So if you take UC, which it has, if you don't give it any arguments, it will use $_ as its argument. So it'll perform an uppercase on that string and then return that into our line. So here's equivalent forms. The block form looks like this. Now, one thing that's interesting is the ForEach being somewhat similar to a map, but it's not quite as concise. We can actually make a map a little bit more concise. See, here we have the map function like we had on the previous screen. We can do an inside-out ForEach where we take the inside of the ForEach loop and put it at the front and then do the ForEach. That is actually faster than map. So you get a little bit of performance improvement by doing an inside-out ForEach loop. Personally, I hate inside-out ForEach loops because in reading the code, you see, okay, $_ equals UC. Oh, what are we doing here? And then all of a sudden you realize, oh, it's an inside-out ForEach. So it's kind of like the if statement modifier where we're putting an if at the end of the line or an unless at the end of the line. It's the same sort of idea, but it's with a ForEach. There's only so much you can do. If you have something fairly complicated, you really can't do an inside-out approach here. So this inside-out is equivalent to the regular ForEach that we're used to. But it's shorter, and it actually is a little bit faster than the standard ForEach form.
Or execution.
Pardon?
What's faster?
When I'm talking faster, I mean execution time. Compile time is usually not that much of an issue. Yeah, question over here.
Does map modify the source array?
That's a good question. And the answer is when you're inside of a map and you modify $_, it will modify the original. That's a side effect you may or may not want to have.
It's an alias.
Yeah, so $_ is actually an alias.
Is the bottom ForEach slower because it's using block?
Yes.
Anytime there's a block, you create a lexical scope, which incurs a penalty.
That's right. And so we'll see that in a few other places where we create a block that it's actually slower because of that overhead of creating the scope.
How much slower are they?
It's not much. Like most of the things I'm pointing out here are shaving off little bits here and there. They're not huge performance gains. There are some when we get to like the sorting algorithms where there'll be major performance gains. But a lot of the stuff really depends on your data. If you're processing a lot of data, it will make more of a difference than smaller amounts of data. So probably for most of the things we do, the performance is not the issue. It's the clarity of the code, being able to maintain it. It is recommended that we use map for creating new lists. That's where it performs best, and that's where it actually internally has been optimized for. Whereas ForEach is intended for optimizing existing lists, for modifying existing lists. So if you're going to modify a list, use ForEach. If you're going to create a new list, use map. Now there's some exceptions to that, but that's the general rule, and this is actually a Perl best practices recommendation. One of the things that we might want to do with a loop that could be done with a map or ForEach is dumping out the contents of a hash. So just for an example to show how that might look, this is probably something you've seen before. So we'd say ForEach, sort keys, name of the hash, and then it's going to dump out the key and its associated value with the hash. So that way you get a nice pretty output. We can also do that with a map. It's a little bit different looking, but essentially works the same. And then we have the inside-out form for the ForEach, which does the same thing. So these are all equivalent. You'll get a little bit better performance out of the inside-out ForEach on this. But usually if we're doing output, performance is not the problem.
Is there a way to pick the iterator variable for map? Like, or stuff $_.
It is always that, but you can easily assign it to something else to create a lexical and scope and assign
Assign $_, so it's still a big $.
So there's a minor problem with this, and this is usually frowned upon, and that is map here is being called in a void context. It's returning something that we throw away or we're ignoring.
Bunch of ones.
It's a bunch of ones because the result of the expression in the block is true, meaning a print returns a true if it succeeds, so you end up with a bunch of ones. Not useful information, but probably not the best practice. But just we wanted to show you some alternatives on how to do some of this stuff. Now, one of the gotchas here with map is that the block for map that you give it is in list. It's expecting a list, so it's list context. Most of the time, that's not going to cause a problem. Damian Conway recommends in his Perl even better practices to explicitly use scalar map expressions. So you are to put scalar in front of every time you have a block for map. Now, in this case, we don't put scalar in. Local time returns two different things depending on how you call it. If you call it in scalar context, it'll return a nice formatted string of the current date and time. But you call it in list context, and it will return a list of numbers corresponding to the year, minute, second, hour, day of the week, and all that stuff. Just a bunch of numbers. So we're going to end up with our dates array is a whole bunch of numbers. It's not going to be what we really wanted. So the alternative is that we use scalar as Damian recommends, and then we get the correct context. We get a string that has a nice formatted date in it. However, sometimes we don't want scalar. So for example, we're taking text lines from a file and we want to get all the words out of it. We do a split on $_, forcing that to scalar context. It's going to tell us how many words we had rather than the actual words. So the fix for that is we take out the scalar. And that gets us what we want. So there are times to use scalar and there's times to not use scalar. Damian recommends always using it. I complain a little bit about some of the best practices because this always thing kind of bothers me, because there are times where you do want to follow the recommendation. There's times when you don't, and it doesn't make sense to. But the great value in the best practices is that it makes you aware of the problem. Otherwise, you would run into it and not even know what was going on. So I like the raising of the issue. Sometimes, and some of you that have seen and done a lot of map code, you may see a plus on front of the block, and you wonder, what is that all about? What's going on here? What's happening, you want to say?
You're forcing it to become a hash ref, right?
Well, the problem is it doesn't. Yeah, it doesn't know what it is.
Yeah.
Makes it an expression.
Yeah. So it forces it to be an expression. And there's actually an efficiency issue with the Perl compiler, because it has, when it first hits that opening brace, it says, what is this? Is this a hash ref or is this a code block? And so it'll guess initially. And so you fiddle with this, and you'll find that you'll say, that should work, and I'm getting a syntax error. It's because it's thinking it the wrong thing, so you may have to put a plus on there. So beware of that issue. You don't run into this very often, but you sometimes do have that. Here I'm mentioning about the void context being a problem that we talked about it before. It's a minor problem. Just be aware of that. Some people will criticize you for that, but sometimes it's exactly what you want. If we wanted to create a hash using map, we can do that an element at a time, taking $_ and creating a hash for it. Anything we can do to an element of a list to generate some other information, we can use to create a hash. This just is one example of doing that. For those of you that don't know, -m gets the last modified age of a file in days. So like the file is 3 days old, 10.7 days old, that sort of thing. And you don't give m an argument, it will operate on $_. We can do the same thing in a ForEach. That's the equivalent function in a ForEach, or the inside-out version. And be aware that for is a synonym for ForEach. So we actually don't have to type those extra letters for each. If we want to skip in map, we use an empty array or an empty list. So if there's an element that we don't want to have that's being processed through, say, oh, we don't want this one, just return an empty list. So in this case here, we're taking a bunch of numbers. We're checking to see if it's less than 10. If it is, then we keep it. If otherwise, we throw it away. And Grep does that sort of thing. So here we have our example of map. Grep, that does the same exact thing, is a little simpler. These two, the map and the Grep here, are functionally equivalent. So you can essentially simulate a Grep with a map. But it's more concise to use Grep. Grep, its block is expecting not a list like map does, it's expecting a scalar Boolean. Boolean scalar context. Boolean scalar context is when Perl has an expression, it evaluates it and it says, is this thing true or false? The way it tells if it's true or false is it says, well, what's false? 0 is false. The floating point number is exactly 0.0 is false. The empty string is false. A string with only a character 0 in it is false. And undef is false. Everything else is considered true. So if we have a test for a Boolean here, so we have it like an if statement, whiles expect them as well, until, I mean there's a bunch of them that expect true false type things, that Boolean scalar context. A 0 is considered false. 400 would be true. -1 would be true. The string false is true because it's not one of those 5 values of Boolean false. The string with 2 character zeros in it is true. If it only had 1, it would be false. But there's 2 of them, so it's true. We have a variable that we haven't created before and we're using strict. It will be undefined. If we undef a variable, it will then be false. So this is the Boolean scalar context that Grep is expecting. So some examples of Grep. We can have anything in that code block. It will evaluate it in scalar Boolean context. So we can have a regular comparator type expression. Or we can have a file test. Is this a directory? We can actually perform some operations in there that actually gets rid of duplicates. We can do a match, a regular expression. Or we can actually test it. If it's one of those 5 values of Boolean false, it will drop out and disappear.
Do you have to explicitly put the dollar under in there, or does it default to that?
You have an expression of some sort.
Yeah, you have to have something in there.
So that's the expression.
Yeah. Otherwise, I think you'll always get false. Yeah. Do you see how this works for the duplicates? So the first time we come through, this hash does not exist. So then what we do is we stick $_ in that hash, and then we test it. We say turn it off, so we negate that. So if it was a true thing that came in, we would end up with it negated. So it would be false, so that it wouldn't come through. And then we add 1 to it. So the next time we come through, it's already there. Its value is 1. Negate it, false. It won't add it to it.
Does that still work in like strict mode? Because it usually wants you to create things.
You would create the hash before you go in it. You would say my %h.
Command doesn't whine if it's on.
It's the keys.
Whereas if it said plus equals 1,
double plus doesn't care.
1, 0.
So
I'm
H,
talking about the hash.
H is a lexical variable now that has already been created, but the key itself is what you're creating on the first time.
That it was creating the hash.
The Q plus plus an undefined value is 1.
Yes.
Okay.
This is not the only way to create a list with no duplicates. There's a number of different ways. There's actually, in the more utils, there's a unique function which will do the same exact thing, which is probably more clear that actually that's going on. This is a little fuzzy. You have to think about it and figure out what it's actually doing. That's basically about all there is to grep. You're looking for something. If it matches, if it's true, it returns that element. Pretty basic. Now, the next most interesting thing we have is sorting. Let's talk about some of the basics of sorting. So we can call sort in 3 ways. We can call it with no arguments, with nothing except the list we want sorted, in which case it'll just do the default sort. We can call it giving it a subroutine as it uses a comparator, or we can give it a code block to do a comparator. That comparator function, it needs to know how to order. This tells us how to order those things. That comparator directive is required to return either a -1, a 0, or a +1. If it's a -1, then the elements that it's comparing are in order. If it's a 0, then the elements are equal. If it's a 1, then they're out of order. So what happens is when sort needs to go through the list and shuffle things around to get them in order, it will grab 2 elements from the list and it'll say, I need to compare these. How do you want me to order these? And then it calls the comparator with those. Well, how it gets those to us is in $A and $B. Those are 2 global variables. And we have to, in our comparator, mention $A and $B and say how to compare those 2. Typically, like if we want a numeric compare, we would just say $A, numeric compare, $B. This is sometimes called the spaceship operator.
Does sort treat -1 and 0 differently? They kind of would both be in order, wouldn't they?
0 and -1?
Yeah.
Well, 0 means that they're in order, so it doesn't need to swap them. But -1 means they're in order. Well, actually, 0 means they're equal, so it doesn't need to swap them. But -1 means that they're in order, and it doesn't need to swap them. But there is a case with 0 where you will want to swap them if you have a secondary key. And that's why where the 0 comes into play, and we'll see that when we talk about having multiple keys for sorting. So you sort first by one thing, and if those are equal, then you sort by the next. We'll see an example with dates. We'll talk about that. Because we need a -1, a 0, and a 1, and the comparison operator, CMP for strings, and the spaceship operator for numerics, those are very convenient because they provide exactly what we're looking for. But we don't have to use those. We could use anything as long as it returns -1, 0, or 1. And we'll see an example of that a little later. So the basic sort, an ASCII collating sequence sort, is very simple. You just give it sort, the list, and it returns a list. And it sorts it in ASCII collating sequence. And remember that your uppercase letters will sort and come before the lowercase letters in that. So that might be a little disconcerting. There's ways we can get around that. And then if we want to do a numeric sort, we just have to say $A, numeric compare $B in the code block. Those two sorts, those are the most common ones you will use. Knowing those, that's probably 90 or 95% of the sorts you'll ever have to do. But you can do so much more with sort. So for example, you need to mention, this is the default sort. It's actually just doing a string compare of A and B. So it's equivalent to saying nothing. If we wanted to reverse the sort, there's several ways we could do that. One way is reverse A and B. So instead of getting a -1, we get a 1. Instead of getting the 1, we get a -1. So we just reverse the A and the B, we get a reverse sort. Not all Perl programmers will know that right off the top of their head. They may not have run into that before. So that might be a little cryptic for some. So you may want to use a reverse function, which we'll show in just a minute. But before we get into that, I want to show you about sorting with a subroutine as the comparator. It's a little tricky because what you have to do is you create a subroutine that's going to do some compare. Here we're doing uppercase, so we're going to do case insensitive sorting. Create our subroutine, create a reference to the subroutine, and we give that reference to sort. And it calls that subroutine. I've never seen anybody do this in code. Everybody uses the code blocks.
Word compare. You could use the word compare.
No, it doesn't work. Yeah, I've tried all sorts of goofy things trying to get compare to, giving it this directly doesn't work. Yeah, it's kind of finicky that way, and so I think a lot of people don't use it. That's one of the reasons, because they couldn't get it to work.
I always try to do it as a subroutine. I was like, I don't know why it doesn't work. All right, code block it is.
Yeah, and the code block is essentially an anonymous subroutine in place, is really what it's doing. And be aware that you are not allowed to have recursion in your subroutine. That would be bad. So let's look at a little bit more complicated sorting. We can sort on anything that we can access based on $A and $B. So it doesn't have to be just A and B we're sorting on. We can sort on something you can get to through A and B. So for example, here we have some list that's like a line from a file. And we want to grab the fifth thing on that line and sort by that fifth thing, whatever that is. So we take A, we split it on space. This gives us an array of all the things on that line. So it's essentially the words, if you want to think of it that way. We do the exact same thing with B, getting an array of all the words on that line. And then we compare, string-wise, element 5 and element 5. Anything we can get to through A and B, we can sort on. So we could actually have, we could get very complicated. For example, we could go and through A, do a query in the database and get some value out of the database. Some of these things that we might want to do with A and B could be quite compute intensive. It might take a while, which means we probably want to do some sort of optimization. Let's look at some other ways before we get to the optimization, some other things that we might want to do. So you've probably seen something like this, where you sort the keys from a hash, and we get our sorted keys. But we can also sort by the value, not just the key. Anything we can get to from the A and the B, we can sort on. So in here, we have the keys we get from the hash, just like we get the keys from the hash here. But the keys will be just the keys there. We want to sort here by the value. So we get to the value associated with A, compare it with the value associated with B, and then these sorted keys will be in hash. They will be in the value order, not in the key order. Now let's look at the example where 0 comes into play as a return comparator value. This is where we do a complicated sort of a date. This is something that you might actually do, where we have our date comes in as MMDDYYY. So we've got a month, day, year format, which is a common American date format. And as computer programmers, we've kind of fallen into this thing where we always should have the year first, then the month, then the day, then everything automatically sorts. But the rest of the world doesn't work that way. In fact, you go to Europe, or even Canada, or Australia, and they have day, month, year. Yeah, I know, it's terrible. It's terrible. So what we need to do is we need to say, let's sort by year first. And if the years are equal, then we need to sort by month. And if the months are equal, then we sort by the days. So we have our dates that we're passing in. So we have a date in A. It's a date string. We split it on a dash. That'll give us our pieces, our month associated with A, our day associated with A, and our year associated with A. We do the exact same thing with B. Get our month with B, day with B, year with B. And then we compare the years numerically. We actually could have compared them string-wise. It wouldn't make any difference on the years, because that will always be 4 digits. And if they're different, it knows what to do, and it'll drop out at that point. Because we have an OR here, if the left-hand side of an OR is true, it drops out at that point.
Until you get to the year 10,000, then 10,000 is less than 900.
Okay, you maintain that code. Yeah, 5-digit years. I'm not sure we're going to get to that point. So, but if these are equal, it's going to be a 0, which would be the left-hand side of an OR, which means it's false. So it'll have to do the right-hand side of the OR, which means it goes to the next one and compares the months. If it knows which it is, meaning the result is non-zero, it'll know how to order them. If they're equal, though, then it'll have to go and compare the days. So this is how you do sort by one thing, then by the next. And you can chain this as long as you want. We could put hours and minutes and seconds on this if we wanted to.
And if the A is on the left, means us in the middle, right?
Yeah, and if you wanted to swap the A's and B's, you could have them in reverse order.
So the sort itself doesn't really do much difference with the -1 versus on 0. It's the comparisons.
It's the comparison is that.
Operator has the short-circuiting.
Yeah, the short-circuiting of the log functions.
Why would that have a difference?
Is this a stable sort?
Comparison side, it makes sense.
Yes.
Okay, so the zeros do matter. What? It's a stable sort.
Yes.
It won't change the order of things that are equal.
That's correct.
It's a merge sort.
Unless the timestamp is different.
No, that's not it.
It doesn't, it just says done.
Yeah, we're not showing the time here, but yeah, if there were more to it. Now this example is a bit contrived. This is actually derived from a problem that we had where we had somebody with administrator privileges, but if they were, and we needed to make sure we had an administrator account, and so we're going through a list of accounts. We wanted to get the administrator account to be the one that was selected. However, if there were no administrator accounts, we needed to pick the oldest account. And so we did a sort on that, and that was actually too complicated to fit on a slide. So I came up with one that said, let's just say we have a deck of cards, and we always want the king to be first in the list. If there's a king, we want it first. Otherwise, we don't care about the order. And so in this case, we are manually returning that -1, 1, or 0, rather than having a comparison operator. You don't have to use the comparison operators. So if A is equal to king and B is not equal to king, then they're in order, because A is a king. But if A is not a king and B is a king, then they're out of order. We have to return a 1, otherwise we return a 0. At the returning 0, we could have gone to another step and we could have said, okay, let's compare the rest of them. So we could have stuck a compare in there, but I want to just say we don't care about the rest. So this actually could be a very useful thing. Now, because map, grep, and sort both take and return lists, we can chain them together to make some very powerful functions. So in this case here, we're generating a list of JPEGs. So we get a list of file names, we sort them, we pull out just those that are JPEGs. So we're looking for a dot followed by a JP optional E, might have an E in there, and then a G, and then we lowercase those, force them all to lowercase, and that becomes our list of pictures. Yes?
Would the grep, is that lowercase?
With some capital G in there, right? Capital J, capital E.
Yeah, wouldn't it make more sense to put
Yeah, I should have put an I right here.
Or map. Switch the map to grep, right?
Or I could have switched the map and the grep, and it wouldn't make any difference at that point.
If
Yeah,
you switch the
good
grep
point.
and Sort though, then you end up doing sorting fewer items.
That's correct. It could have swapped the sort. In this case, it actually doesn't matter that much how much you shuffle them around. If I had the I on the end of there, but that's a good point. Okay, now let's look at optimizing a sort. So if we have something that's kind of expensive as a comparator, where it takes a while to do it, and we may have to call that multiple times per element to be able to get things in the right order, that could be very expensive. So we want to be able to do that just once. So let's create a list of files. Here we'll put into @files the files in the current directory, and let's say they look like this inside of our array, inside of the @files array. If we just call a regular sort, that will sort these in order, but we don't want to sort by the file name. We want to sort by the age. So we would do that this way. We would say sort -m $A, numeric compare -m $B. But the problem with that is -m is called twice every time it does a compare. And it'll be doing it lots of times. Now, there may be some internal caching that helps with some of that, but still, it's going to be a lot slower than just doing the -m once and saving it. So let's do that. We want to save it. So what we do is we'll make a map. We're going to build this in parts here. So if we have a map function, and we say, let's create an anonymous array with the element 0 being the thing we're actually interested in, and then our comparison value here as the next element in that anonymous array. So we essentially are building a parallel array with the information that we want in the second part of the array. So the age of the files, 2.9, 1.1, 3.1, and so on. Very convenient. So order will actually be an array of anonymous arrays. So then what we want to do is we want to sort based on this other array that we've just generated. So we will pipe that stuff from map into a sort where we're comparing element 1 in A against element 1 in B. But sort returns this whole mess in sorted order. What we want to do is we want to strip out that blue stuff, that extra array that we created. So we'll do another map where map just returns element 0, which will be the yellow. So we built that second part that we needed, so it would save it, sort on that, and then strip it off and throw it away. That is the Schwartzian transform.
Then you run the painful M once for each.
You run
Just
once.
How many things, how many sorts?
That's correct. You only run it once. And so if you have a very expensive comparator operation, this can save you tons of time.
Will that double bloat the memory, having a copy of the list and another copy of the list?
Yeah.
But memory's
Yeah.
cheaper than time sometimes.
Faster.
You look at the alternatives. So that's the Schwartzian transform. And the way you recognize it is it has that map sort map. So the key points to remember if you're going to do a Schwartzian transform, it's actually not that hard, is it has a map sort map. And then you have your comparison, whatever kind of compare you want, whether you want a string compare or a numeric compare, you have to have some comparison there between the elements. And then you have to do your little magic that generates the comparator that we're putting onto that anonymous array, that second array. So here we're doing minus m. So those are the three things that you need to worry about. The rest of the code stays the same. It's essentially a formula.
If you want to do chronological order, you could just switch A and B.
Sure.
It's
Or-
do it first and then all.
Yeah, if you wanted to reverse them, you could do that, or you could call the reverse function just in front of the whole thing. You could just put reverse right here.
So you could just files, or do they use that with other types of data? I mean,
Anything you can sort on that could be expensive, you can use the Schwartzian transform, and it'll give you an improvement. Now, there's some other forms that are similar. Give us a little performance gain. Orcish maneuver is similar to the Schwartzian transform in that it's performing the operation that we're comparing against once, but instead it's saving it in a hash, which we're calling cache, and we're using the OR, and that's where the name comes. It's an OR cache, so they decided to call it the Orcish maneuver. It's popularized by Joseph Hall. It's a lot simpler to code than the Schwartzian transform. It doesn't have quite the performance of the Schwartzian transform, but it's still pretty good. And the key here is that you only have a sort. You don't have a map sort map. And your test and the compare.
Orcish would probably be quicker if there were a lot of dupes, right?
Yeah. Yeah, if there are a lot of duplicates, it's going to be faster. That's a good point.
The biggest penalty would probably just be generating the key, hashing the keys.
Yeah, you still have to save that somewhere, whether you're saving it in a parallel array or saving it in a hash. Somehow you've got to save that. So the key things that you will need is you have to have a sort, your particular comparators, and how you're going to compare those two. There's another form called the Gutman Rossler form. This is faster than the Schwartzian transform, but it's quite complicated. And you have to do quite a bit of custom work for each one, because what you're doing essentially is you're bypassing the building of the parallel array by building a string. We're using an sprintf to use our string as our comparison, so we'll just do a default sort compare. We don't have any arguments to sort besides what's passed in from map. And then we tack on to the end of this string the thing that we actually are sorting. And then we strip that first part off and just keep the thing that's at the very end, which is just in this %s. See, our dollar underscore goes in that %s. Yeah. It depends on your data set, but you can get easily 1.5 to 2 times the performance over the Schwartzian transform with this.
It only works with strings.
It's if you can convert it to a string. So it's
String of file.
yeah.
You have to get it back to whatever you.
So it's faster, but it's harder to code and it's less readable. So that's a little bit of a problem. But it doesn't work for all types of sorts. Some other list and sort options. Look in list util. One of my favorites in there is shuffle. If you want to randomize your data, instead of putting it in order, you want to unorder it. Reduce. That's a very powerful construct. Any, first, max, min. There's a lot of fun stuff. Unique, out of more util, and n at a time. Those are some fun things. Sort key. It may be faster than the Schwartzian transform or the Gutman Rossler one. And then we have the sort naturally, where it looks and sees what kind of thing you're sorting. And it'll sort numeric when it's appropriate. Sort maker is actually recommended by Damien Conway. Do we have any questions or comments?
I got the labeled sort word. You don't put the ampersand in there or the backslash or just put the dumb word, which is kind of weird.
Are you saying the subroutine?
Yeah, on the full slide again. So compare, sort, just compare, no comma. List.
Okay. Okay. Well, cool. That's it. Further resources, if you want to go look online, there's plenty of stuff in CPAN. Perl Monks is a good place to look. Of course, Perl Doc is always a great place. Randall Schwartz has Stonehenge Consulting, which has some great information about Perl in general, but also about map, grep, and sort. And if you want to do any profiling to test the performance, you can use NYT-Prof. That's a great tool to use. And go check out Robert Van Dam's presentation on profiling, where he talks about this. That's I don't know when that's scheduled.
I think it's tomorrow.
Is it tomorrow? Okay, yeah, that's a great little tool, a lot of fun. All right, thank you.